So now let's move on to choosing the right model. And supervised machine learning models learn from labeled data to make prediction using input-output pairs during training to understand the relationships and predict labels for the new data. So in supervised machine learning, it's used for two types of problems or tasks, which is classification problems and regression problems. And classification problems refers to predicting a category, like whether someone has diabetes or not. And sometimes you will see CLF. Sometimes you will see CLF, which is short for classifier, that's used as a class estimator. And also regression problems, which refers to predicting a number, like the selling price of a car or a house. So now let's start off with picking a machine learning model for a regression problem. So let me import the libraries that we will need. Import pandas as PD, import numpy as NP, then from sklearn.model_selection, we're gonna import train test split. So now let's upload the housing data or housing data frame, and this will be available in the description for you to download in case you want to follow along. pd.read_csv housing_data.csv. Now let's look at our housing data frame. And you see this is all of our features, and the target is what we're trying to predict, which is the price of the house. So next I'm going to set up a random seed. Let me write a comment. So np.random.seed, and we'll set that to 42. And if you set yours as 42 and you're following along, the data will be split the same way as mine. So now let's separate the features and the target. So we set x equal to housing data frame dot drop, and we want all the columns except the target. And we set the access equals to 1 because we're dropping a column. Set y equals to housing_df, and we want our target column. And the target column is the median house price in hundreds thousands. So let me write a comment and split data into train and test subsets. So x train, x test, y train, y test, and we set that equals to train test split. The first arguments is take is our x and y, and then we set the test size to 0.2. And what this means is that 20% of the data is going to go for our testing, and the other 80% will be used to train the model. And the train test split allows us to evaluate model performance of a model on unseen data. So now let's run that, and then we're gonna import our models. So the first model we're gonna import is a ridge regression. So from sklearn.linear_model, we want to import ridge, and the ridge regression adds L2 regularization to the linear regression to prevent overfitting by penalizing large coefficients. And then the next one I'm gonna import is from sklearn.ensemble. I'm gonna import the random forest regressor, and then I'm gonna import linear regression. And this should be a capital L. Let's run that. And now it worked. So now we're going to create a dictionary called models, which contains all the classification models we've imported. So models equals, I'm going to create it like a dictionary. So we're going to set ridge to equal ridge. Random forest regressor. We set that to the model. Next we're gonna do the linear regression we imported. And we could put more models in here to try to get the one with the best score, but I'm only gonna use the three we imported. Set that equal to linear. Next I'm gonna create a empty variable called results. And now let's run that. And next I'm gonna create a for loop, which is gonna loop through our model dictionary items, fitting the model on the training data and appending the model name and model score on the test data to the result dictionary. So let me create this for loop. So for model name and model in this models dot items, I'm gonna write model dot fit. Then we're gonna take the X train and the Y train, and this is where the training occurs. Then I'm gonna call our results, append our model name, and set that equal to the model dot score, which is X test, small x, and Y test. So now let's see our results. Now let's run that. And you see here we got a ridge score of 57%. Random forest regressor gave us a score of 80%, and the linear regression gave us a score of 57%. So the model we would pick for this problem would be the random forest regressor because we got the highest score. Later on in the course, I'm going to show you how to do a RandomSearchCv and a GridSearchcv to better improve this model score. So now let's move on to picking a machine learning model for a classification problem. Let me just write the heading. Picking a machine learning model for a classification problem. And let's load our heart disease data frame. Now let's take a look at our data frame. And all these features will be used to predict the target variable. And the ones means that someone has heart disease, and 0 means someone doesn't have heart disease. So let's separate our features and targets. So we set x to equals heart underscore disease dot drop. And we want to drop the target, and what we want to drop is the column, so we set the axis to 1, and we set the y to the heart disease, the target column. Now let's use train test split to split the x and y into training and test sets. So x train, x test, y train, y test, set that equals to test to train test split. And the arguments it takes is our x and y. I'm gonna set the test size to 0.2. And we're gonna do the same thing we did for our regression problem. We're gonna create a dictionary called models. Put an equals here, run this cell, and we have to put a y here. Let's run that. A comma here. So now let's create a dictionary with the classification models. So we're going to set models to equal, well, first we have to import the models. So from sklearn.svm, we're going to import linear svc. Then from sklearn.neighbors, we're gonna import k neighbors classifier. And then from sklearn.ensemble, we're gonna import the random forest classifier. Now let's run that. And now we can create a dictionary which contains all the classification models that we have imported. So So models equals to linear SVC. I'm gonna set that to the linear SVC function. KNN, and just copy this. And then I'm gonna copy this. Then I'm gonna set an empty variable called results. Let's run that. And now let's create a for loop that loops through the dictionary items and fits the model on the training data and append the model name and model score on the test data to the result dictionary. First, let me set the random seed. So if you're following along, our data will be shuffled the same. And then so for model name and the model in our models, and then we need the items. Items, and the model dot fit the X train and the Y train. And this is where the training happens. And then we're gonna append our empty variable with the model name and the score. And that take the arguments of our X tests and Y tests. And now let's see the results and run this out. And you see for our linear SVC, we got a model score of 83%. Our K-neighbors classifier, we got a score of 63%, and the random classifier, we got 83%. So then we could choose either the linear SCV random forest classifier, and then we could better improve it using GridSearchcv or RandomSearchCv, which we will do later on in this crash course.